So as you add more VMs, the only thing you can do to try and provide an experience that's commensurate with the physical world is to add larger and larger spindles or more caching and make a larger investment in the storage infrastructure. So storage ends up being about 80% of the cost of VDI. So, it's arguable that virtualization really is giving you anything, because in the process of virtualizing, we've kind of taken one set of costs and transformed it for another set of costs. There are three very, very hard technology problems with VDI, and Atlantis focuses on solving these three key problems. One is a storage capacity problem. So if you think about VDI, we're taking the user's desktop operating system and application image and sticking that in the data center. And that basically, from a simple math perspective, means that if each user's image is about 40 gigabytes times 1,000 users, we're talking about X, 40 terabytes worth of storage in the data center. Now, there are some smart technologies from a storage perspective that you can deploy to try and shrink that. So you could use thin provisioning, for example, or you could use data deduplication as another way to try and shrink that. But the problem with both those approaches is they are coming from the old storage world where they were applied to things like backup and things like transactional data. And so they inherently don't understand the kind of I/O patterns and working sets that VDI represents. So they really do a poor job of allowing you to cut the amount of storage when you try and use thin provisioning and data deduplication to solve this. So let's look at thin provisioning, for example, because this is kind of bad as the major storage savings technology for VDI. So the idea with thin provisioning is very simple. You have a copy on write layer that basically allows each user to get his own Delta file, and they share a common master image. So there's one common image of an application, of operating system, etc., and there's a Delta file on top that you divert all writes to. So the idea is you can share one image among a lot of users, and it works in principle because you can really thin provision and get off very, very small. You can start really, really small. But thin provisioning is NTFS unaware. And NTFS does some very simple fundamental things because of its architecture, where it allocates a bunch of transient blocks for, scratch space. It basically allocates blocks to write some data. And then instead of going and zeroing those blocks, it simply goes and updates the master file table saying those blocks are now available. But from the storage perspective, storage doesn't really know that those blocks were ever freed up. So it constantly just keeps giving up blocks whenever NTFS requires them, but never really gets them returned. So as a result, all those nicely thin provisioned volumes tend to grow and become as large as the master disk itself over a very short period of time. So it's interesting, every time I see customers with POCs, and they're really happy on day one of the POC because they've just thin provisioned everything. But on day 5 of the POC, the thin provision volumes are the size of the original master file, and they've lost all the storage savings. And so really, it's not thin provisioning's fault. It's just that it's NTFS aware. There's no really interesting way to make the storage system aware of these kinds of intricacies. Let's take data deduplication, which is another technology that's been thrown to try and solve this problem. Now, data deduplication, if you remember, comes from the post-process backup world. The idea is we take some data, we write it, and then we kind of analyze each block of data to find duplicates. And if we find duplicates, we delete the duplicate and put a small little reference in its place. So the premise of data deduplication really is that first I must write my data to primary storage so I can analyze it. In the context of VDI, that means that you need to write all your data to disk first, which means you need to buy the peak amount of storage in the first place. So data duplication is kind of an oxymoron in the context of VDI because it forces you to buy the full storage system and then optimize it and only use a small part of the capacity that you have. So it really doesn't make sense in the context of VDI. That's a big problem. And so what Atlantis did over here is we built a layer of software that really understands at the I/O level what it takes to compose and decompose a desktop. So we built a virtual machine image of a desktop on the fly, and in that process at the I/O level are able to analyze all the writes and reads that are going back and forth between storage and server, and solve the thin provisioning problem, as well as deduplicate all the I/O in flight as it goes between server and storage. I'll talk a little bit more about that when I talk about the architecture. The second problem is a very, very complex problem, and it is purely a result of what we're trying to do with virtualization. 10 minutes, okay, I'll try to wrap this in 5 and do some Q&A. Second problem is purely a result of virtualization. You see, for the last 10, 15 years, as storage companies built their storage arrays, they try to make these arrays very fast, and the most important technique they had to do that was what's called white striping, or intelligent data placement, which is they took a bunch of data and placed it over multiple drives so that they could parallelize the reading and writing of all the data. And similarly, the operating system vendors wrote lots of intelligence into their drivers that the drivers would do what's called write aggregation, which is collect a bunch of writes and send them at one shot rather than writing many tiny writes and slowing the array down. And all that's great in the physical world where you've got one server or one desktop writing to one storage system. But when you put a bunch of these virtual servers and virtual desktops on one hypervisor, the hypervisor now has to schedule each and every guest's I/O, which basically means it takes all those aggregated writes that these systems are generating and chops them up, send them to the array, because it has to be fair to every workload. It has to give every workload just enough time to do its reading and writing. This is an I/O elevator problem, so what ends up happening is that all the sequential I/O that used to be nice and fast now gets chopped up in a random I/O and put on the pipe to the storage system. And storage systems, because their mechanical spindle base, are just horrible at random I/O, because the disk heads need to realign to read and write all this random data. So as a result, you bleed another 25-30% of the capacity of your storage array because of this randomization of I/O, and it's a big, big problem. And if you wondered why your VDI is so slow, it's a combination of things, but one of the biggest contributions to the fact that it's slow is this randomization of I/O that's going on. It's a very hard problem to solve. And Atlantis solves this because we sit inline in the I/O path, and we aggregate I/O from across all the desktop operating systems, analyze it, and then do what's called write coalescing, which is reorder the writing and send it to the array as a stream of sequential replay. So as a result, the storage array reads a lot better. It basically it's got a strong set of sequential read-write going on most of the time, and as a result, it completely solves this problem. The last part I'll talk about is a very expensive problem, and that's the fact that unlike server workloads, which are easy to virtualize, desktops are very hard to virtualize because they have a very non-deterministic I/O pattern. So if you look at a server, like an Exchange server or a web server, you can basically model exactly when it's going to peak and when it's going to be a low activity period for it. And as a result, you can kind of provision all the infrastructure very, very scientifically for it. A desktop, on the other hand, because there's a human being at the other end, it's very, very hard to predict what he's going to do, especially as you have more diverse applications and more diverse types of users on the VDI infrastructure. So as a result, there really is no meaningful way to scientifically provision how much storage and how much capacity you build into the VDI environment, and therefore you tend to need to over-engineer these environments so dramatically that the CapEx proposition is just unbelievably large as a result. I'll quickly go into how Atlantis solves this problem. What we've built is a appliance. Actually, it's all software, but it's put on a generic x86 appliance. And this appliance, it sits inline on the I/O path between server and storage. And what it does is it proxies the storage environment to your servers. So, the picture is very simple. At one end of this pipe, you've got your storage systems, and that can be a NetApp, it can be an EMC box, it could be direct attached storage, it could be anything. It's just a bunch of spindles with some software on it. And at the other end of that pipe, you've got VMware ESX, or you've got Citrix Zen Server, or you've got Microsoft Hyper-V. In between those two ends, is our appliance, and this appliance proxies the storage. So therefore, because it's in line, all I/O that happens between the server and storage, we get to inspect it. And what we effectively do in line in the data path is analyze all the I/O. And because we understand NTFS I/O so well, we can do some very interesting things as a result. We characterize the I/O, we fingerprint it as it slides between server and storage, and that allows us to determine exactly who is making that I/O request, which guest, which operating system, which subsystem of the operating system, whether it's user or whether it's application.